first off, again, I want to reiterate that we do have an online textbook. Quite a few of you have already gone to it. Quite a few of you have not. So the online textbook is at Runestone Academy. It is 100% free. I went out of my way to make sure that we have a free textbook so you do not have to pay for the privilege of an online textbook that you wouldn't have access to when the class was over. This one is free, and I think you can get into it even after my class is over. It doesn't have a closing date that I'm aware of. And even if you can't get to the actual class assignments, you can get to the general free textbook from their website. Yours will not look like this. This is mine. So, yeah, I put everything in dark mode. Somebody tell them to just pull the door really hard and they can come in. But you don't have to put it in dark mode. I like dark mode. So this is all of the different things. This is just taking you straight into the textbook. In our class page, okay, if you go to this little person right here, and you do the drop-down menu on it in dark mode, it doesn't work because it's a free textbook. But you can go to the assignments one. And I don't know exactly what the student view looks like. Let me see if it'll let me change to student view. No, of course not. Anyway, if it's yours and you use the drop down here, you'll have a lot less choices than I do. But if you click on assignments, it should list what assignments you have. It won't give you the option to edit them, but it should show you the due date and let you click directly to that section of the book. Now, I did not assign any of the labs. I did not assign any of the extra practice problems. All I assigned was the textbook portion where you read it, and there might be a couple of example things in there, but I didn't put any extra work there. I'm already giving you labs and assignments. I don't want you to do extra work in the book. I just want you to read it. Now, you're going to say, why is there a grade attached to it? Because y'all won't read it if I don't make you click on the pages to prove that it's been. Now, could you go in and just click all the pages and not actually read a word? Absolutely, but you've only hurt yourself. I'm doing the best I can here to force you to read the textbook. Some of the dates, the due dates are not correct, but I think I have those right now marked as hidden. You are only responsible for the sections that I have posted in the weeks that we are doing. When I created the assignments, it defaulted to the due date to the day I was creating them. And I got in a hurry and forgot to go change them. Sorry. I forgot. I'm fixing them. So right now, you should have already read the general introduction, data and variables, and debugging. Those were all due yesterday. I'm going to grade them beyond yesterday. If you keep clicking on them, it'll still mark that you've done it, and I can click the button when I go to the grade book. It says grade everything, even the late stuff. I'm going to take everything late. I'm going to wait till we get back from Labor Day, and I'm going to pull all 4 chapters because Turtles and Graphics assignment is going to be due after Labor Day. So you'll have until Labor Day to go and click on all those pages and get your points. Is it a lot of points? No, it's 10% of your grade. You could blow the textbook off altogether if you're willing to lose a letter grade. If you don't do the textbook, you can't get an A. Even if you did 100% on everything else, you're still going to fall short of that A. Or fall maybe dead on it if you get 100 on every exam and every assignment and everything else. All right, so this is the textbook. That's what it looks like. Now you're going to say, well, how do I get there if I miss the directions? Well, that's a good question. So if you want to know how to get there, we can do that from our Coursed-In page. And I can change this to a student view. Just remember that the online textbooks are great. You get what you pay for, though, sometimes as far as functionality. The content's great for that textbook. I love the content. I know one of the authors, worked with her years ago. The user interface is very simplistic because they don't have paid professionals doing it. That's why it looks very simple. All right, so in here, I do everything on from the content page. You can find everything you need from my class on the content page. If you go back to general information, there's one for the virtual lab, there's one about tutoring, and there's one for accessing the online textbook. And there's directions. I'm not reading them all to you. You are adults. So if you run into any problems, because there are a couple of people that have run into problems, you need to come email me and set up a time for me to look at it before or after class. And let's get you into the textbook. All right. Are we all good with that? Thumbs up? Okay. So I'm optimistically expecting that everybody will be enrolled in my textbook by this time tomorrow. Just throwing that out there for you. All right, so let's take us back out of here. Well, we can stay in there. We can stay in that. So this week is week 3. So we're going to start talking about loops, and we're also going to introduce turtle graphics. Why turtle graphics? Because they're cool and they let us do some remotely interesting things besides just typing text. Gives us some visuals to look at. And you all know what a turtle is in real life. So it relates. So we're going to start with the PowerPoint. Today, I'm going to go through all the PowerPoint. We're going to talk about it. It's going to have some code examples in it, but we may or may not type them out while we're doing it. Just depends on how the flow's going. On Thursday of this class, we are going to do what I call follow along coding. And I'm going to do the entire, well, I'm going to do as much of the lab as we can get done in the class period. I'm almost positive we can get the whole lab done. And then you'll be turned loose to do the assignment on your own from Thursday to Tuesday, or Monday night at 11:59. Does that, has anybody got a problem with that kind of scheduling?
I do.
All right. So I'm going to jump over to my PowerPoint. Before I jump into the PowerPoint, anybody have any logistics questions about Coursed-In, the textbook? Oh, wait, that's what I was going to do. Due dates. I realized that I have confused the issue on assignment 2, which
that's what I was just.
Yeah. So I realized after getting several emails from several different classes that I don't remember what I told which class about due dates because the internet has been a pain for all of my courses. So it was technically due last night. I am going to push that due date to, okay, I'm open to suggestions. I don't want to give you a whole nother week because some of you did it and I'm proud of you for that. But I don't want to push it a week because you still have other work to do. We can't just push everything and keep pushing. So if I give you till Friday to get this one submitted, are you all okay with that?
Yeah, it's cool, but the attachment is right here. I try to open it.
Okay, hold on a second. Let me while we're here, I'm going to go and change that due date. That way I can't mess it up again. So that would be assignment 2. And I'm going to change it to 11:59 on Friday. So there we go. Now, you had a question about, let me go back to the content page. So what was your question? That it's not opening for you?
You don't the doc for the art assignment, but I mean, we can just open it in Microsoft Word. And,
Yeah.
Right.
Yeah.
So, just download it, put it in like docs or so.
So I'm going to be honest with you. The reason I do the doc instead of a PDF is because I think it gives you a little bit more flexibility as far as being able to open it. I could be wrong. I'm not a Mac user, so if you're a Mac user, I'm not real good at helping. But you should get a document like this that just has the directions, right?
That's if you download the Microsoft 365 on your personal desktop. If you want it to open like that.
You do not have to download 365. You can go, because you're a student, you can go to your one login page right here. And you can click Office 365. And it will open up to this window, but if you go to the apps, you can get any of the Office apps and it will run in their browser. If you want to download them, that's up to you, but you don't have to. So you got Word, Teams, Outlook, OneDrive, the whole 9 yards. I assume you get everything I get. Yes, ma'am.
And then it's the textbook for the class. Do we always have to go through One Stone Academy to like log in?
I find it's easier. Courseden doesn't link directly very well to Runestone Academy. I try, but you get what you pay for. It isn't integrated into the LMSs very well because you get they don't have a developer on their side to make it all. So that's why I'll have to transfer all your grades manually. It's okay. It's just data entry, you know.
It's not that bad.
Nah, yeah. I can run down a column of numbers pretty quickly as long as you used the same name when you register at Runestone Academy as in Courseden, no problem. I just sort it alphabetically and I just run down them. Now, if I ever make a mistake, because I'm human, just email me and say, I think you put the wrong grade in, and I'll go check it. Because I'm human. All right. So any other questions about the assignment? Yes.
It's like my third. It's at the same.
Right. So you put your West Georgia
Yeah.
username there and your West Georgia password there, and it should go.
Yeah, but
I need something for this, but I don't.
No, you shouldn't need anything for that. Okay, I'm gonna fix it. I'm gonna try to fix it. Okay, come here and enter your password because I don't know your password. Yeah. So, username should be the one from one login. That's your one login username.
Yes.
So, after password, I don't want to know your passwords. Not that I would remember it in 3 seconds, but you know. All right, and okay. So so instead of going to the client, we need to actually go.
Get to the student thing, but
No,
get to
oh, I said. Instead, it's on several computers.
yeah. It happened on Thursday and my PC.
Grab another one of the computers today, just a different one out of the box, and see if you get something different. Otherwise, I'm recording this, so everything I do today, you can be able to watch from home. But I don't know how to fix this. I'm gonna be honest with you. I don't know what's going on. So try one of the other computers. This one I'll just hang on to and see if I can. I'm gonna hope it's just this computer. Yeah, but they fixed the network now, so I'm hoping that you won't run into that again. Let's hope. All right, so the internet has got to get sorted. It's just got to get sorted. All right, let's try to do this PowerPoint. And I will try to go and edit this video and take some of the unnecessary chatter out of it. So we're going to talk about iteration. And iteration is a fancy word for we're going to do something repetitively and we're going to use a loop. Because you iterate through a loop, you take steps and you go over and over again. So just a fancy word for we're going to repeat things. Now, having said that, the first thing we want to talk about is the drive principle. And the drive principle says we don't want to repeat ourselves. But that basically means we don't want to type the same exact line of code over and over and over again if we can use a different structure to accomplish the same thing. So if I wanted to print my name is on the screen, instead of using 6 print statements, there's a more efficient way of doing that. We can use something called a loop. And we basically tell the computer, I want to do something until this condition is met. So we have 2 types of loops. We're going to talk about 4 loops today. 4 loops are what we call counting loops. You're counting up to something or counting down from something. And we also have conditional loops, which are while loops, which we're going to get to later after we talk about conditions, that run while something's true. So one has a true false test and one counts. So let's talk about counting loops today. But the drive principle we want to think about as we build bigger and bigger programs, that we don't want to just type code over and over again if there's a better way. We want to do things that are reusable and repeatable with the least amount of actual physical work for you. Because the less lines of code there are, the less likely you're going to have a typographical error, which causes bugs in your code, right? So we're going to talk about loops. We're going to repeat a block of code however many times. the for loop is set up where you use the keyword for. You have some sort of variable. And in this case, we're talking about a list. So we're going to have a variable that holds what we're working on right now. And it's going to go to this list and it's going to do whatever code statements are indented under the for that many times. It's going to do, this is a special case kind of for. This one says, I'm going to do these statements until I've done every element in the list. So if I had 10 numbers in that list that I wanted to print out, the for loop would go for num in list, and then the next line would be print num. And what num would do at that point is it would go to the first element of the list, get that number out, print it, jump back up and says, is there anything else in the list? Oh, there is. Let me move to that next spot, get it, print it. And it's going to do that until it hits the end of the list. And then it's going to say, I'm done. And it's going to jump down out of the list, out of the loop, and do the next block of code. It makes much more sense when you see it working. Why does my computer not want to do? Yeah. So this is look there. There'll be a huge delay between these two things. So for course, because this is a list of courses, in our list, we're going to print the course. So the first time through the loop, course is going to grab CS1300, come down here and print it to the screen. The next time, once it's printed, then it's going to go back up to this and say, oh, I got another element in my list. I'm going to grab math 1113. I can't speak today. Go down and print math 1113. Then it's going to jump back up and say, I'm going to go check my for again. Course is now going to jump over to get English. It's going to go back down, print English, come back up and say, course. Do I have anything else in this list? I do not. So I'm done. And then it would, if there was a lot of code down here, it would just jump down to there. So it does it until it fails to have another element to jump to. And once it does, it exits the loop. So the loop ends, yes. This loop has one line of code in its body. So this is the for definition. We're defining the for loop on this line. This is the body of the loop. Everything indented is called the body of the loop. Those are the items of code you want to run when the loop should run. And we use indentations in Python. If you don't indent the line under the for loop will run. The variable will change till it gets all the way to the end, but it will not print anything because the indents are wrong and it doesn't know that that line is part of the for loop. Yes. So
this, Wilson,
uh-huh.
is it like where when it says for course, whatever is first, it goes from left to right, like whatever is first in the bracket gets put next to print?
It always moves left to right. Just in a list, it's always going to go from start to finish, just like we're reading it.
Okay. And then it does each of them individually, right?
Yes. Wave the computer up here again. God, something's wrong with this computer. All right. So every time I change the slide, I have to wave my laptop at the screen. All right, sure. Okay. So this is just a couple more examples. We're going to deal with lists later in the course too, so this will come very in handy when we start manipulating lists and creating lists of our own. But for right now, anything in the square brackets is seen as a list. Each element in the list is separated with a comma. I is commonly used as the variable in a for loop. This goes back to old school programming, and I is short for index because the position or the index in the list is where you're at. So the first time we go through the loop, I would be 0. It goes to the 0 element. Y'all realize it? How many of you realize computers start counting at 0? Pretty good handful. So we'll take a little sidebar here for a second. Computers think 0 is a number. So when I start counting and I want to say this is a list, it has 4 elements. The index number for these elements is 0 through 3. Because the first element is at position 0, the second element is at position 1, and so forth. You will often hear an off by 1 error talked about when you're talking about loops. That's because our brains have been conditioned to start counting at 1, 2, 3, but the computer's counting at 0, 1, 2, 3. So oftentimes loops will go 1 too many or 1 too few because we haven't accounted for the 0. So just keep that in the back of your mind as we go through. And you'll notice on the assignments and stuff I give you that often it has a part 0, part 1, part 2, because I'm trying to get you used to everything counting from 0. I'm going to ingrain it into your heads, and you'll just start counting that way. You go 0, 1, 2, 3, 4, and people look at you like you're crazy. It is for me, but I've been doing this longer than most of y'all's in alive. Didn't work that time. All right, so this is how we do it if we're doing with a list. And when the slide changes, we'll talk about how we're going to do it if we just have a range we want to be in. There it goes. The delay would be bad. So if we want to, we could have a loop work on stuff that's not in a list. Say we just want to print out the sum of 1 to 10. So we want the loop to run 10 times. We want it to add things together. So we're going to use what we call a range function. And you have 2 options when you're using the range function for loop. You can give it just a starting point, and then it will go, just a stopping point, and then it will count up from 0 to that stopping point. Or you can give it a start and a stop and a step. So I could say, I want to count from 2 to 20 with a step of 2. So what does that do?
2 plus 6, 8.
Yeah, it does the even numbers, 2, 4, 6, 8, 10, 12, because it jumps 2 steps. It's counting by 2. So this one's very useful. The reason step is in brackets is because you don't have to give it a step. If you don't give it step, it just automatically assumes the step is 1. It's going up by 1. Questions so far? Have I lost anybody yet? Am I talking loud enough for the people in the back? Okay. So while we wait for the slide to change, and we wait. I'm gonna do a lot of editing on this one, aren't I? Yes, sir. But let's not talk about that. Let's not confuse the issue right now. Let's not bring up the exceptions. So as my student here has pointed out, there are a few languages that break the rule of counting from 0 and start at 1. Just like the English language has all sorts of exceptions in their spelling and pronunciation rules, there are some exceptions in programming. Not nearly as much as the English language, but there are some. Don't worry about it. This Python and Java, which are the two you're primarily going to be using in the near future, count at 0. All right, so this is an example of a for loop that is going to execute 4 times because it has a stopping point of 4. So it's going to execute with a body is equal to I is equal to 0, I is equal to 1, I is equal to 2, and I is equal to 3. So it did it 4 times, but the index number is not 4. Does that make sense?
So is the index number the number that you end with?
No. Well, yeah. Hold on, yes and no. So the index number, I will be whatever the index number is in this particular case. But the stopping point is 4 because you want the loop to execute 4 times. The index number what goes from 0 to 3 because that's 4 steps.
Okay.
This is why loops are super confusing to beginning programmers. Do not feel bad about asking me questions about loops. You will see loops on your tests that's coming up shortly that will say, how many times did this loop execute? What is the output of this loop? And I'm going to do that to you because I need to know you understood it. I'm not being evil. Well, not for that reason. My sons both think I'm evil, but I'm just trying to make sure that we got a very clear understanding. What you'll learn with programming languages is you have to understand the core basic steps before you move to the next one, because if you don't understand this building block, it makes the rest of the semester harder. So the second example has a starting point and an ending point. So it's going to start at 10 and it's going to go to 14. So starting point is inclusive. It is included. Ending point is exclusive. It is not included. So if you needed 15, then you would have to make your ending point 16. Why did Python decide that one was included and one was excluded? Have no idea. I would love to find the person that thought that was a great idea and argue the point with them, because it seems non-logical to me. It should be either both be included or both be excluded, in my opinion. But my opinion doesn't count because I wasn't there when they created Python. The last one here has a step. So it starts at 0, it goes to 11 with a step of 2. So it's going to go 0, 2, 4, 6, 8, 10. A step of 2 would put it beyond 11, so it stops. Right? So in this case, 0 is an even number. Not really.
If we were to start at 1,
Mhm.
would it, I'm guessing it wouldn't include 11? Or would it?
Would not, because 11 is exclusive. It is excluded. So it'd be 1, 3, 5, 7, 9. That makes sense? That's why I hate the fact that one's included and one's excluded, because it's hard to wrap your brain around. Remember, I'm teaching you a whole new language. It is not something that everybody is going to grasp really quickly. Some people will, some people won't. I'm teaching you to think in a way you've never been taught to think before, because this is not how K-12 education has taught you to think. You're supposed to memorize and regurgitate. Now we're going to think logically and mechanically and computationally. Yes, ma'am.
So what determines how many numbers will be in the bracket when you get the range and then put them in there? This zero,
When you
one,
set
two.
this up, that tells you how many numbers are going to be in there. The user, however, where they set the ranges, that defines this.
So it has to be less than.
Less than the endpoint. So this one is 15. So when it hit 15, it stopped. And we need to completely skip that slide because I have, just ignore this turtle slide. I was supposed to take it out. So when it skips this one, it goes to the next slide. Any day now, computer. So magic wand. So the accumulator pattern is really just where you want to use a loop to sum up a value. So I wanted to add 1 to 10. It's going to take 1 and then add 2 to it, and then add 3 to it, and then add 4 to it. So it's a fancy way of saying we're going to use a loop to total up or sum up a value. A good example of this is when you take an Excel spreadsheet and you click on the whole column and you hit the sum button. That has using an accumulator to add them all together. It did it in the background where you didn't have to, but that's how it happened. But there's a lot of vocabulary you're going to learn in this class. That's the key. I have to advance 2 slides and then go back. Except it doesn't want to go back. There it goes. Somebody remind me why I went into computer science and like technology.
It's fun.
That's it. It's the mystery. It's the mystery. Obviously, it doesn't want me to show you an example of the code for an accumulator pattern because it keeps skipping it on both directions. So while we're waiting on that to come back, oh, there it is. Yeah, I just have to plan on moving on. So this is the code that you would write for an accumulating loop. So in this one, I'm going to set up a variable before the loop starts and set it to 0. Oddly enough, I'm going to call it sum because I'm summing up numbers. You should always make your variables descriptive, because I promise you that if you go through and you write a whole block, big, long program, and you use variables like X, Y, and Z, you will forget what X, Y, and Z stood for. And if you turn it into me, I will have no idea. So if sum works, use sum. If you don't like using sum because it is a keyword in some programming languages, you can use total. So for I in range 10 to 101 with a step of 10, what's it going to do? It's going to do 10, 20, 30, 40, It's going to include 100 because we went to 101. So then it's going to come down here. And so I, the first time is going to be 10. Sum is 0 when we started because we set that before the loop started. So it's going to 0 plus 10 and put that into sum. The next time through the loop, I is now 20. It's going to take the 10 we already had, add the 20 to it, and now sum is 30. The next time through, it adds 30 to 30, and you get 60, right? Always remember when you have a math equation like this, or a statement with an equal sign in it, it does whatever is on the right-hand side of the equal sign, and then stores it into the variable on the left-hand side. If it's the same variable, it takes the number or the value from before, does the math, and then overwrites the old value with a new value. So if you don't want to lose the old value, don't set it equal to itself. Because once you set it equal to itself, it erases the original value and replaces it with the new value. One equal sign in programming languages generally means I'm assigning a value to a variable. Two equal signs checks to see if they're equal to each other. So you'd have equal equals if you're trying to compare them. If you're setting a value, it's one equal sign. And then once this loop is done, I can unindent and do another line of code. Everything that's indented goes with the loop. Everything that is not indented is not part of the loop. Yes? Yes.
I have a question. So for when you're, so since you, the number that you start at is 10, right? Because that's the first number to the left. And then we're trying to get up to 101, but then we're counting up by 10 since that's on the far right. So when you add 10 plus 10 and you get 20, and then you do another 10, you get 30. Why did you say we add 30 plus 30?
Because I is going up by 10 every time. Sum is going up by what we added.
So like, so the I is going up by 10. That's going to be separate from the sum.
But let's see if this works today. Nope. So if I had a whiteboard, I could draw you a chart. Let's see. Where to do draw. So on this slide, I could make a little table, maybe. Enable editing. Now draw. I want to keep up with I, and I want to keep up with sum. Right? So to start with, sum is 0. And that's before we have an I. So sum is already 0. I, the first time through, is 10. Right?
Yes, because you start at 10.
Right. When I run the loop through, sum becomes 0 plus 10. Or 10, right? Then I jumps up to 20. This becomes 10 plus 20. I jumps up by 10. So it goes to 30. And then it's 30 plus 30. Is that making more sense now?
I'm starting to understand it a little bit better.
So what the value of I is independent from what value is in sum. I is going up by 10 every time the loop runs. Sum is adding I to itself. So they're different. They're independent.
And so for the next run, you would just add 10 to 60.
Nope. I will become 40. And now we have 60 plus 40. So basically, this is the old sum on this side, and this is going to be I added to it. Drawing on the screen is hard, so don't make fun of my writing. Does that make sense?
That makes more sense.
Now, I'm going to give you some more practice with this. This is what I call a T-table. And I highly recommend them when you have very complex loops to make sure that you're getting what you think is going to be your results. All right, back to what I was doing. And if you really want me to, I'll go back and put that slide that I just saved with the T chart on it in the PowerPoint. Or actually, I'll probably clean it up and make it much neater handwriting and put it in the PowerPoint. I can do that in the next 24 hours or so.
Okay.
If I forget, somebody just email me or remind me. But let's talk a little bit about modules. If you've had a programming language like Java or C++ or C#, this would be the equivalent of classes. So what it is most programming languages nowadays are what we call object-oriented, and they have some pre-built libraries. So things that are going to be used commonly are already built, like how to do addition, how to do math, high order math functions. So there's like a math module already built in Python that you can get from the standard library, and you don't have to go and reinvent that wheel. You don't have to teach the computer that pi is 3.14, whatever afterwards, right? And no, I didn't memorize anything past 3.14. Not a math major. But it also has some other things, like it has a string module that has all sorts of things that you can do to strings. It has a turtle module, which we're going to play with in a few minutes, that allows you to use a cute little turtle to draw simple things on the screen. So we can access these modules by importing them. And we do that at the beginning of our code before we use them. But we also have this entire standard library, which we're going to hope opens. Yay, it did. That you can get to anytime, anywhere that has to do with the Python language. And it lists all of the available pre-built stuff. And you notice the scrolls for a very, very long time. So I tried to link, when we get to it, I try to link you to the right place, but it doesn't always work. This search bar right here will save your life. So today we're going to talk about turtles. So I'm just going to put turtle in here. And it gives me a truncated version or list of things. I just want to go to the basic turtle module. So I'm just going to click on this first one. And now it specifically is just about turtles. And it lists all of the functions and actions that you can do with a turtle. And once you click on one, so let's talk about basic drawing pen control. So I now can go over here and read about it. So there's a POS, which gives you the turtle's position, not what you're used to POS standing for. There's a function for clear screen. That's one of the reasons abbreviations are not always good. It talks about beginning the fill, ending the fill, and it gives you a few examples of how to use some of those things. So this comes in handy when you're going, I know somebody has already figured out how to do the square root of a number. I can go to the math one and I can search for square root. Or in this case, I go to the turtle and there's got to be a way to clear the screen without me having to erase every line I just drew. So I can go and look up clear straight. This, I'm gonna promise you, as you get more and more into your programming experience and your computer science, computing careers, learning to research these and use them to your advantage is going to be a lifesaver for you. So good searching and researching skills are vital to being a computer professional. I call it Google foo, but you need to have a lot of that. But these are not flashy sites. Usually they're very boring and basic, but they're a lifesaver when you can't remember what that command was. And if the command takes a parameter, which we're going to talk about later, or it needs a piece of information to run, like color needs to know what color, you can come here and say, oh, does that need to be in quotes or does it not need to be in quotes? Then you can come here and check instead of guessing and hoping that you figure it out.
It's like a way to kind of check your work and
In a lot of respects, yes. It also keeps you from writing code that already exists in your code, in your programs and stuff. Now, a lot of times as professors, we will force you to write code that already exists just for the practice and to teach you the steps for doing that. But as you move further along, save yourself some heartache and time. But nope, wrong window. Gotta hate it when you go to the wrong window. But so in the PowerPoint, there is a link to the standard library. You also can find it by Googling Python standard library, Java standard library, C# standard library. And 90% of the time, the first link is going to take you where you want to go. Sometimes a sponsored link will get you messed up. But if you look for like Java's owned and by Oracle now, and used to be Sun, now it's Oracle. C# is a lot of it's a Microsoft driven thing. Not all of it, but .NET definitely is. Python comes from python.org. So we're going to use the turtle module in class for the next couple of weeks. You get your first big project will be your turtle drawing something. Your lab and your assignment this week will be your turtle drawing stuff. You're going to code it to draw things like a square, triangle, circle. Circles are really hard. Luckily, there's a circle function already built for you. So that's where we're heading, is towards that. So this is some example code. So the first thing we would have to do is import the turtle module. I am going to tell you that my preference, and I am the one in charge of your grade, so import statements should always be at the top of the file. Python absolutely will let you put them in the middle of the file, as long as you use it before you call something from that module. Don't do it. It's bad coding. Put all your import statements at the top of the file. If you're going to use turtle and you're going to use math, do import turtle, import math. It will come before the main function. Import statements are one of the exceptions on my orphan code rule. They will not be inside of functions. Generally speaking, they will be the first couple of lines of your code. Why? Because if you get them out of the way, you don't forget them later. And if you also put them all in the same spot, you don't accidentally import the module more than once. Well, what we're doing, that wouldn't be a big deal because it would slow things down. But if you were doing a much more time and memory sensitive thing, it could cause some lag. Not that we know anything about lag with our internet this week. So we're going to import turtle. We're going to create a place for the turtle to live. The turtle needs its own world to live in. In this case, it's a window. So we're going to call the pre-built function turtle.screen because it's going to build a little screen for it to live in. We named it window. Sometimes I name it world because in Java, we called it world. We're going to create a turtle and we're going to give it a name. So you need a variable to hold your turtle once you create it, because if you don't give it a name, you can't yell at it. You can't tell it to do anything because it doesn't answer to hey you. So we're going to give our turtle a name. In this case, we named it Alex. Most of you have met one of our Alexes. That's how these go. And then we can give Alex orders or actions, or in this case, the technical term is we can call functions. So Alex can go to use the standard library of turtle functions and knows what forward means. It knows what left means. It knows what pin up means and pin down means, and right. If it has a left, it has a right. So these are functions that we're going to play with in lab on Thursday. But forward does exactly what it sounds like. Whatever direction the turtle is facing in, it's going to move that, however many pixels is inside the parentheses. And somebody's going to say, how big's the pixel? Tiny. So 150 pixels is going to be, depending on the resolution of your screen, about an inch long. Maybe longer if you have a low resolution, maybe shorter if you have a really high resolution. It's whatever a pixel is on your screen. Left means that it's going to turn to the left, however many degrees is inside the parentheses. So you have to think back to your math coordinate system where you draw the circle and you know how many degrees you're going. So 90 degrees to the left. So if it was facing horizontally across the center of the page and you told it to go 90 degrees to the left, it's going to turn and face up. That makes sense? Turtles by default are always start off in the center of the screen, facing to the right of the screen. I don't know why, that's just the way they programmed them. Turtles are what we call objects. You know, I keep throwing out this object-oriented programming. It means that the program is built around the idea of we're going to create objects that do things. So it's object-oriented. In this case, we have turtles that are going to do functions. Can you have more than one object in your code? Yes. Can you have more than one turtle in your screen? Absolutely, as long as you give them different names. If you create a new turtle with the same name, you will have two turtles on your screen, but one of them will never move again because you have no way to talk to it. Because if you don't know its name, it doesn't know its name, and it's just going to sit there until you clear the screen. So objects have attributes or properties. So a turtle always knows its position. It can figure out and tell you, if you call the right function, what its X and Y location is on the screen you've created. So in your head, when the screen comes up, draw an imaginary cross through it. And the center point is 0, 0. Think about your geometry. Center point 0, 0. The X axis is running horizontal, and it gets larger as you go right of center and gets negative as you go left of center. Y gets higher or bigger positive number as you go up, and it's a negative number as you go down. Math. Whoever would have thought you needed geometry again? Hmm. The functions or methods that you see these turtles using, think of them as actions. Your objects are nouns and the functions are actions. So if I give you a description of something program I want to create, you could just read through it and underline all the nouns, circle all the verbs, and that would give you a starting point on what objects you need to define and create and what functions you need to define and create. Will it be 100% accurate? No, but it does give you a starting point. I'm old school. I print out everything and I use pencils and highlighters to make myself notes as I read it. I underline nouns, I circle verbs, I make a note out to the side and say, oh, I might need a loop here. That 20 minutes or so that I spend on something saves me hours of frustration when I start coding because I already have a plan of action. I'm also very much a visual learner, so I need to see it. Don't tell it to me. If you tell me something, I'm going to write it down where I can see it. So feel free to draw yourself pictures. Make a list. Whatever works best for you. If you don't want to do it on a piece of paper and a pencil because you're the technology generation, digital pens, digital screens, do it there. Save a tree. I'm all for that. But as we move forward, we're going to talk about objects and functions and how they work together. We are not going to create our own modules in this course. You will in CS1 and CS2 create classes, but in this course we're not going to get there. We're just going to use the predefined stuff and make our own functions using it to interact with those. We're good. This Turtle API link takes you exactly to that page I found by searching for Turtle. API is the same as saying standard library. It's just different terminology for the same thing. But if you click on it, it takes you exactly back where we were. Why do we have a whole lot of terms for exactly the same thing? No idea. I'm sorry. It just is what it is. So we are going to move into functions next, but just so you know, while we're using them, functions have a name and they have parameters. So begin fill is a name. It has no parameters. It just has an empty set of open and close parentheses. Every function has open and close parentheses. Some take what we call parameters. It can be 0 to many parameters. So in shape is the name of the function. The parameter is the variable name. So whatever's stored in that variable is going to go to the function. We're passing it data. Does that make sense? GoTo has 2 parameters. Oddly enough, it tells the turtle to go to a specific X and Y location on the screen. So you need to give it an X location and a Y location separated by a comma. They have to be in that order. If you put the Y in first and then you put the X in, it's going to a completely different place because the function is going to take the first number and equate it to X and the second number and equate it to Y. It's not going to read your mind and go, oh, they messed that up. Remember, computers only do exactly what you tell it to do, not what you want it to do. I know I yell at them all the time for not doing what I thought I was doing. Again, X-core returns the X coordinate. It doesn't need a parameter because the turtle is going to tell you exactly where it's at right that moment. Just some more examples. Pin down. The turtles by default have a pin. And every time they move, it draws a line behind it. If you don't want to draw the line, you have to tell it to pick its pin up. And then when you're ready to draw again, you tell it to put its pin back down. So it has commands for pin down and pin up. It has forward, it has go to. Pin down doesn't take a parameter because it doesn't need any information to start drawing or stop drawing, right? But if you're telling it to go forward, it needs a number. If you're telling it to go to an X and Y location, it needs 2 numbers. Yes.
And then like in the last example, you had said that, I don't remember what was in red, but the words that were in red, that's the name of the turtle, right?
That's the name of the function. The name of the turtle is on the left-hand side of the dot.
Oh, on the left hand, so it's
Your turtle is the name of the turtle, because that's your turtle. The dot says I'm calling a function. The function name is the word immediately after the dot. Yeah, and then the parameters list is the parentheses and the stuff inside the parentheses. This first one pinned down has 0 parameters. So this one has 0 parameters. This one has 1 parameter. This one has 2 parameters.
And the first one has 0 parameters because it's pinned down. So
Because it doesn't need anything. If you have a function that needs no information from you or the user, it has no parameters. It just runs. So we didn't do anything else. Like the main function, when we write it out, it has no parameters. And when we call it at the bottom of our code, we give it no information. It just runs. Yes, no, maybe, we good? We're going to skip the multiple objects. So we could have Bob. Bob's a name I use a lot for turtles because it's short. Bob and short. So we could have Bob, and we use turtle.turtle. That's a special function that creates a turtle object. We can change what shape Bob is. We can make the default it draws as a triangle, but they actually have a little picture of a turtle, so you can change the shape to turtle. They have a few other shapes in there too that you can go look up in the standard library. We can change the color of our turtle. So instead of just getting a randomly chosen solid colored turtle, we can change the shell to one color and his feet and head to another color. So we can have a red and blue turtle because, West Georgia colors are red and blue. We can tell it to pick its pin up. We can tell it to go somewhere. We can pin back down, and then we can start telling it to move. You tell it to turn left 180 degrees. You basically have told it to face the other direction. Right does the same thing. It just turns in the different way around the circle. Questions? I don't expect you to understand all of this because we haven't done anything with it yet. Right now, it's just a bunch of words on the screen. Thursday, we're going to draw with the turtle. Yes, ma'am.
So I think I understand basically like what you said in the example before. If the turtle doesn't need to move anywhere, then there's just going to be no number in the bracket or the parentheses.
No. If the function needs no information, there's nothing in the parentheses. So it's not necessarily just tied to movement. It depends on what the functions do.
Okay.
We'll talk about it. You'll understand it better, I think, when we do the examples Thursday.
Thank
Okay, I'm done for today. I'm gonna make a few edits to the PowerPoint, like draw some pictures on it for you. But other than that, the PowerPoint is already up for you.
Is it in the?
It's on Course Center, the content. So if you go to the content page over here on the side, there's one that says PowerPoint.
Okay, thank you.
You're welcome. And I'm gonna try to do that every week, make sure that the PowerPoint is up there. It may not be up there till the day we do it, but there will be a PowerPoint posted. Let me stop this video before we go any further.
Oh, yeah.